Right, so today we're going to look at the U value question. Now I'm going to start with this one. It's a 2009 question. So U value is basically asking you to calculate the heat loss through a section of the wall in this question, or a window or a floor or some part of the building. This question is really nice because the question A is usually repetitive the whole time. So it's usually question A is the same. Question B is similar to this one, or there's another type of option, and then question C is a modification or something to the existing building that could improve the U value. Now, for a U value, we're going to do a table, but first of all, you need to know what you're looking at. So for this case, it's calculate the U value of an external wall of a house, and you're given the following data. So you're given all your thicknesses up on top. So we've got our external render, concrete block, cavity insulation, concrete block, internal plaster, and then we're given the resistance of certain elements or the conductivity. Now in this question, we're given all conductivities and resistances, which is nice. So we also have a couple of things to look out for. Your resistance is what we're looking for. So our resistance of an external surface, my resistance of a cavity, and my resistance of an internal surface. So when I'm doing this question, I'm going to do it out in order, starting from the outside and working the whole way in. So if I was to start this question off, this over. First thing you're going to do any of these U value questions is you are going to do out your table based on the question. So the first thing is my material. That's going to have my first column all to itself. Then my conductivity, which has the symbol small k. My resistivity, small r. My thickness, which always has to be in meters, and it's given the symbol capital T. And finally, the thing I'm looking for in this question, my resistance. So if I just table this off, and this is capital R. So my material, starting from the outside, working my whole way in. I've got my external surface. I've got my external render. I've got my blockwork and my external block. I've got my cavity. I've got my insulation. I've got my internal blockwork. I've got my internal plaster. And then I've got my internal surf. Now, going straight back to the question, I'm going to take all these values straight from the question. So my external surface, I know straight away from the question, it has a 0.048 and it's capital R, so it's over in this column. My external render has 1.43. My concrete block has 1.44. My cavity has a resistance of 0.17. My insulation has 0.018. My concrete block has 1.44, and my internal plaster has 0.43, and my internal surface has 0.122. Now what I'm trying to do is fill out this resistance column the whole way down and calculate all of these together. So my thicknesses of my plasters, remember, it has to be in meters, and we're given it in millimeters for my external render. So 12 millimeters in meters is 0.012. If you can think of it, you're always trying to have 3 decimal places after where it should be. So there's in millimeters, and I move it back 1, 2, 3, what I'm looking for. My external blockwork is 0.1. My insulation is 0.1, my concrete block again 0.1, and my internal plaster is 0.015. Now, there are 2 formulas you need to know, and they're not wrote down for you anywhere, you just need to know these formulas off by heart. So to get my resistance, it is either one of these formulas. It's either my thickness divided by my conductivity, or it's my resistance is equal to my thickness multiplied by my resistivity, this column. Now, because we have nothing in this column today, I can ignore this section over here. Now, what I'm going to do is, for each one of my columns, I'm going to get 0.012 and divide it by 1.43. And I only really need to go to 3 decimal places. So 0.12 divided by 1.43 should give me 0.008. Now I'm taking these numbers just from the marking scheme to help me along. So 0.69. Insulation, this is a big value because it's what keeps the heat in and the cold out. Internal block work, it should be 6.9. Internal plaster is 3.5. Yeah, and that is that whole column filled out, which is what I'm really looking for. Now, to get my U value, I need to add up all my resistances. So we call that RT. So my RT, the total of all them resistances, when I add them all up, should be 6.077. Again, I'm taking just my values from the marking scheme just to speed me up along. Now to get my U value, your U value is 1 divided by my total resistance, which would be, in this case, 1 divided by 6.077, which for me gives me 0.165. I'm going 3 decimal places. Now, if you look back at the question, the handiest way of remembering this is, if you look back in your question, your resistance is measured in meters squared degrees Celsius per watt. Now, my U value is that in reverse. So it's the other way around. It's watt per meters squared degrees Celsius. So you don't really have to learn that one off. And that is the same for all U value questions. Now, if I go back to the second part of this question, it is using the thermal data below and the U value obtained in question 5 up here, calculate the cost of the heat loss annually through the walls for the house specified up here and for a house built in the 1970s with a different U value. Now, they're giving us all this data, but we need to know the formulas to put that into, and there's a couple of them in it. Now, so for part B, first part is my heat loss. My heat loss is U value multiplied by my area multiplied by the temperature difference. Now, my U value is from the question above, so it's 0.165 multiplied by my area, and if I go back to the question, the area of the house is 152, and the temperature difference, just one over here, is 17 take away 6. So my area was 152 multiplied by 17 take away 6. And when I multiply that all out, I should get 275.044 watts. Next part is my heating period. Now, for this question, you are told that the heating is on for 11 hours a day for 41 weeks of the year. Now, you need your heating period in seconds, so you're going to get a huge number in this, usually by the millions. So 60 seconds multiplied by 60 minutes multiplied by the 11 hours a day multiplied by 7 hours a week multiplied by 41 weeks a year. And when I multiply all that out, I should get 11,365,200 seconds. Now, to get at that in kilojoules, which is what I want. So this watts is the same as joules per second. Now I need to find out in kilojoules how much heating I need. So in kilojoules used per annum, that is equal to my 11365,200, so this number above, multiplied by my 275. That would be the answer in joules. Divide that by 1,000, and I should get, I should get 3125930 kilojoules. So that's my energy used per year. Now, next I need to convert that back into my litres. So the litres of oil use. So my litres per year is this value, my 3125930, divided by the calorific value, which I'm giving in the question as 37350. And when I divide them out, I used 83.69 litres. Now, 1 litre of question, so just go back to the question for a second. There's my calorific value I got, and we're told in the question that the cost of oil is 65 cents a litre. So, my cost per year is 83.69 litres multiplied by 0.65. And that should give me a cost of, in euros, 54 euros and 39 cents. Now, that's usually all you have to do, but this question asks you for two things. So it asks you for the house that we calculated up here, which we've done now, and a house built in the 1970s with a U value of 0.18. Now, there's two ways of doing it. We could go through all this formula again and sub in 0.18 instead of up here, but that's a lot of work. Instead, what we can do is my U value, so this is for part 2, my U value from the first part of the question was 0.165, and that gave a cost of 54 euro and 39 cents. So if I wanted to find out what 1, if the U value was 1, I would get my 54.39 and divide that by 0.165. Now, I don't want 1 here, I want 1.8 because that's what given to me in the question. So 1.8 is equal to my 54.39 divided by 0.165 and multiply that answer by 1.8. And when I do all that, I should get a value of 595 euro 14 cents. Okay? And that's the second part of the question, totally finished. Now, a lot of people skip this last part or rush the last part, but at the marking scheme, there is there's 33 marks go for the first part, there's 12 marks go for the second part. So part B is worth 12 marks, part C is worth 15 marks. And if you read the question, it's talking about using notes and freehand sketches to show one method of upgrading the thermal properties of an external wall of a house built in the 1970s to meet the requirements of the current building regulations. Now, there are lots of ways of doing this. You can put external plaster on or external insulation on, you can put internal insulation, you can fill the cavity, you could fill the cavity and put insulation boards, rigid insulated boards, you could put timber battens and rigid insulation, so it's whichever one you know best. What I'm going to talk about is the one I think is just the easiest, so I'm going to talk about pumping the walls full of insulation. So for part C, I'm going to talk about polystyrene beads being pumped into the wall. Beads. Alright, so that's the method I'm going to talk about. So first of all, I'm just going to go bullet points. So holes are drilled in the wall. And the external wall. At regular intervals. Right, so then what happens? So I've drilled holes all over the outside of my house. The insulation is pumped into these holes. And then the polystyrene beads, the insulation, slash in this case it's polystyrene beads. Are water repellent, rot proof, and non-combustible. Now I'm going to just do two quick sketches. So one is going to be the external of my house. So I'm just going to put in, say, a door and 2 windows, and I'm just going to show that there are holes drilled in the house at regular intervals. Now let's just see. So the idea is once you're filling this pump hole with insulation, you're filling all this area up to here, and then you'll go above it the whole time. And then a section through the wall. So there's my external render, my concrete block, my cavity, my concrete block, my internal rivet. And I'm going to just show that this is insulation. Sorry. So label my diagram, external block, insulation, and internal block.